This is an introduction to experiment 6A, molar mass of a volatile liquid. As the name suggests, we're going to determine the molar mass of a volatile liquid. Now, what is a volatile liquid? Well, the word volatile just means that something will vaporize easily. So common volatile liquids would be things like nail polish remover or rubbing alcohol or gasoline. They'll evaporate very quickly at room temperature. So what we're going to do is we're going to take a small sample of a volatile liquid and put it into a container and vaporize it, make all of it into a gas. The nice thing about gases is we can use the ideal gas law to calculate the number of moles of the gas. We need to measure the pressure of the gas, the volume, and the temperature, and then we know what the ideal gas constant is. And from that information, we can calculate the molar mass, the moles of a gas. So we can rearrange this equation, and N, the moles of gas, is equal to the pressure times the volume divided by the gas constant and the temperature. Now, how are we going to measure these different quantities? Well, the temperature of the gas is going to be assumed to be the same as the temperature of the hot water in which the flask is submerged. So we'll measure the temperature of the water with a thermometer. There is a hole in the lid of this flask, and because of that, we know that the pressure of gas inside the flask will be the same as current atmospheric pressure. That pressure can be measured with a barometer, or we can use a weather app and look it up. So that's how we'll do that. The volume of the gas will be the same as the volume of the flask. Now we're going to use a 125 ml volume Erlenmeyer flask, but that does not mean that the entire flask has a volume of 125 milliliters. So we're going to have to determine the volume of the flask all the way to the top. So we can do that in two ways. Both involve filling the flask with water to the very top. One method involves weighing the filled flask, and then you can use the density of water to determine the volume, or we can take the volume of water and measure it directly using a graduated cylinder. And that's the method that will be used in this video. So once we have the moles from the ideal gas law, that's this part right here, moles of substance, then we need the mass in grams. So that's going to be weighed, but how do we weigh a gas? Let's look at the experimental setup here and talk about how this experiment goes. So here we have our Erlenmeyer flask, and it's submerged in a hot water bath so that we can cause the liquid to vaporize. We're heating it using a hot plate because these volatile liquids are flammable, so we don't want any open flames. We have a thermometer here so that we can measure the temperature of the water. And here's our flask. The flask is going to be covered with a foil lid, and there will be a little tiny hole in it. So what we're going to do is we're going to put some of the liquid, like 4 or 5 milliliters of liquid, into this flask, cover it, and submerge it in the water. As the liquid heats up, it will begin to boil and vaporize, and it will begin to fill the flask with the liquid in the gas form, same substance. And what it will do is it will displace the air, and the air will come out, and then eventually the excess gas will begin coming out of the pinhole in the lid. Now, of course, the gas that we're using is not nice and brightly colored like that. It looks like air. And so we're going to continue doing this until we can't see any more liquid in the flask. And then we will know that the whole flask has been filled with the gas. And at that point, we'll take the flask out. So all of this will blow away. This is done with good air ventilation. Little technical problem there. When we take this out of the water and cool it down, this gas at the warmer temperature will begin to condense. And it will condense back into a liquid, and we'll start to see the liquid forming again in the bottom. Now, there won't be as much liquid because some of that escaped through the hole, but there will be a little bit left. Sometimes students are concerned because there's liquid in their flask at the end, and we're supposed to heat it until all of the liquid is gone. Well, the liquid is supposed to be there because this liquid is the gas that was filling the flask, and now it has condensed. And so we can weigh the gas because these are the particles that compose the gas filling the flask. So before we start the experiment, we weigh the flask empty and dry, and now we can weigh the flask again with this little tiny bit of liquid in it, and that will be the mass. So that's the mass we need here. So we'll take the mass in grams and divide it by the moles of substance. Something I forgot to mention about the ideal gas law. Remember that the ideal gas constant, R, is equal to 0.08206 with those kind of messy units, liter atmospheres over mole Kelvin. And so to calculate and end up with an amount in moles, the pressure needs to be in atmospheres. The volume needs to be in liters. And the temperature needs to be in kelvins. So there will be some unit conversions that you need to do. Then you can plug those numbers into the equation, find N. We get the mass from the condensed liquid, and then we can put it together here and calculate our molar mass.